Example 13. Find the equations of the normals to the parabola 4y is equal to x squared at the points negative 2, 1 and negative 4, 4. Show that the point of intersection of these normals lies on the parabola. So the curve is 4, y is equal to x squared. Now y will be 1 over 4 x squared. And on differentiation, our dy dx will be 2 comes forward times a quarter, that's a half, x to the power 1. So at the first point, negative 2, 1, the x-coordinate of that point is negative 2. So feeding negative 2 into dy dx, that will be a half times negative 2, giving us negative 1. So the gradient of the normal grad normal will then be negative 1 over negative 1, which is equal to 1. So our point is negative 2, 1. If we take another point, xy, to lie on the normal, then y2, which is y, minus y1, which is 1, over x2, which is x, minus x1, which is negative 2, will give us the gradient of the normal, 1. So that's y minus 1 will equal to, that simplifies to x plus 2. So in rearrangement, that's y will equal to x plus 3. So that's the equation of the first normal, number 1. So the second point, negative 4, 4. Our x-coordinate is negative 4. So dy dx will be a half times negative 4, giving us negative 2. So grad normal at that point will be negative 1 over negative 2, giving us a half. So similarly, our point here is negative 4, 4, and if we take a general point, xy, to lie on the normal, then y2, which is y, minus y1, which is 4, over x2, which is x, minus x1, which is negative 4, will equal to the gradient, which is a half. Okay, so if we multiply through, that will be y times 2y minus 8 will equal to, this simplifies to x plus 4. On rearrangement, that's 6 minus 2y plus 12 is equal to 0. And that's the second normal. So to find their point of intersection, we solve 1 and 2 simultaneously. So we put y from 1 into 2. And equation 2 will then become, that's x minus 2, we feed y from 1, which is x plus 3 from equation 1. Then plus 12 is equal to 0. So x, that's minus 2x minus 6, then plus 12 is equal to 0. So negative x plus 6 will give us 0, and x alone is equal to 6. So to get y, we shall feed x into equation 1, and that's y is equal to x, which is 6, plus 3, giving us 9. So the point is 6, 9. So to prove that this point lies on the curve, it must satisfy the equation of the curve. So that's 4 times the y coordinate, which is 9, will be equal to the x coordinate, 6 squared. So 36 is equal to 36. Hence, the point lies on the curve.